Hey everybody, this is Larry. This is the last day of July, of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And also just, if you're here, congrats on finishing July. Hope you did it. Hope you enjoy it. I'm going to do it again for August, so stay tuned and kind of check it out with me. Okay, so today's problem is trapping rainwater. Just want to remind you that I usually solve this live, so if it's a little bit wrong, a little bit weird, just fast forward or watch another video. It'll be okay. Do whatever you need to do to learn, right? Okay, so this problem is trapping rainwater. So I think this is a almost stereotypical problem. I think like you hear it a lot. So let's kind of see what the situation is. Compute how much water can trap after raining. Okay. I feel like I vaguely remember the feeling about this problem, but I don't actually remember the solution. So maybe that'll be interesting. So okay. So what does it mean by trap, right? So that means that for each height, you go to the next one that is greater, right? Okay. So that means that for each number, we look to the left to see a number that is greater. Oh, and then to the, yeah, and then we can do that. Or something, I'm still trying to articulate it. I think articulating the problem clearly will be worthwhile, but yeah. So okay, so I think that's just it, right? For each number, we can figure out the next number that is bigger, and then that'll trap all the water on the left side and on the right side. And you always have a sort of a, if you look at this as a monotonically increasing sequence, it would be kind of like a pyramid type thing, where there's only one thing in the middle and on the top, or the highest thing would be on the left or the right, right? So okay. So I think one phase this way, there should be a solution. I think you can probably also recognize that the next number larger than this number is also you can exploit that to kind of think about a mono Q solution. I have a video on mono Qs, and I think that will keep, if you do it that way, it will make things a linear time. But I think even if you am able to get the n log n solution, you're most of the way there. Unless you don't know mono Q, then I guess I apologize for that. But let's go over the video on mono Qs. I think that would be good, helpful. So okay, so I think we just have to go. Yeah, let's do that. So here, for let's just say for symmetry. For symmetry, we only look to the right, because then we can just flip the thing and then go to the other direction or something like that. You could just choose, it's arbitrary for sure. But okay, so now we start from the right to left. I know this is a little bit backwards and weird. Then for each number, we go to the next number that's equal or greater. And then we figure out the number of how much water it can trap. And that part is just a math equation, maybe. Is that true? Yeah, okay. We'll play around with that idea in a second. Because I think the thing is that, let's say here to there, what is the, how much water gets trapped, right? Well, you pop this off, and then you have to do some compressing thing. Maybe that part isn't as easy as I know, but let's play around with that, and we'll play idea, huh? Let's just go right to left. Heights. And for index in range of 1 1. And then we have a, did I say mono Q? I think this is actually a mono stack, sorry. Because you're pushing things to the right and then you're always popping it. But sometimes I mix them up. That's my fault. But I think it has the same idea of keeping the invariant of what is max, right? I used to explain that a little bit better. So I definitely have videos on those, so definitely, I don't know, search for those. But yeah, so okay. Index, so heights of index, let's see, right? Current height is equal to this, and then we want to do while stack. So what does it mean when it goes lower? Okay, let's say we have a so we want to go to the right. Here, let's say we want to go to the right and we look for the nearest number. So that means that if we see a number that is smaller than this one, we pop it and we add the current height differential, because that's the way that we're gonna calculate it, right? Yeah, I think there is some maths there. This is a little bit awkward. No, I think I'm trying to do too much. I think it's okay. I see. Okay. I'm just trying to think about my head rectangles. So let me just pull up my Paint app real quick to kind of show you what I'm thinking about. Okay. So basically, you have something like this, and let me actually use straight lines. So you have something like this, and let's just say you have something like this, right? And then you have, maybe in the middle, you have things in the middle. And then the question is, the natural thing to do maybe just to fill out these squares. Let me change colors. Like, we get the, oops. We get the area by adding, let's say this one, we add this chunk, and this chunk together, right? I think that's a natural way to add to get the sum of the trapped rainwater. But maybe a different way to add it is actually, well, this goes down. So then here, here there's nothing trapped. Here there's nothing trapped, and then once we're here, we can do some accumulation with let me change the colors again, with this rectangle going from left to right, and then this rectangle going from left to right, and then this rectangle. And if we sum up these rectangles, I think that will be, well, it should be obvious that they're equivalent, but also it's easier to do mathematically, not easy. But yeah, okay, let's get rid of this. And okay, so I think now we should have a reasonable idea to play around. So that means that the top of the stack, and is greater than this current height, greater than or equal to, we can actually stack that pop. What we actually want to do though is keep track of stuff as well. So this is how I would normally do it, but you have to keep track of the area. And to kind of add that in, we have to keep track of the total sum. I think that would be good. So yeah, so the running sum. So every time this happens, we think, okay, if this is greater than the previous number, then we let's just do width is equal to 0. Keep track of the width as well, maybe. I'm not sure about this one, so so stay with me. Okay, so that means that, and now we actually want the stack to be two-dimensional. So so stack will contain height and then total, maybe. Does that make sense? No, I think I need another one which is width, so we can keep track. But in any case, so then now every time we pop it off, we want to do width. Let's just do current height, current total, and current width is equal to this. And the current height doesn't matter, so I guess we just, and then yeah, And then when we put it on, we go height. This is kind of annoying, actually, but I mean, this is what we would do, but I don't think this is enough. Because basically now we go, okay, how do we add it to the total, the overall sum, right? No, I think we're good. Okay, yeah, okay. Total water is equal to 0. Excuse me. And then here we want to pop up the stack. Of all the things. So this isn't going to be right, but I just want to look at the code because, as we said, we only do it one dimension, right? We have to do it the other side as well. Is this right? No, this should at least have non-zero. So this is clearly wrong. I expect this to be either 1, 2, 3, 4, either 5 or 1. That's awkward. Oh, this is all 0. That's why. Okay, I have to do one more math thing that I'm missing. So okay, so the difference in height. Okay, so I did need a height. So now we have to think about the rectangles that we're doing that are horizontal. So the width is going to be that width. Is it? Let's see. So the previous width plus 1. Is that right? Now this should be the width here of the thing. Then now once we pop, we get the width of it and then the total. And then the total is going to be the previous total plus the total that we're adding. So that's going to be the, oh, I see. That's just collecting the total. But then we have to get to the next number. So, okay. So now we have the total and the width. So then now we add width times, okay, well, if length of stack is greater than 0, that means that we have found something to the right. So let's do stacked. And then total we added by, we don't care about the previous width because we're not popping it, but we do care about the height. So it will be the height differential. So, and you know that CH is bigger than height. So we have this times width. Maybe this is right, or more correct. Should be more correct. Whether it's correct is well. Oh, this should be width. Let's see. No, this should be right. Maybe. All right, let's just take a look at the stack at every time. Do some debugging. Okay, so we start at 1. This is 1. That's fine. 2. Also, that's true. Here, the third one is the weird one. It's weird in that. Wait, did I have the signs wrong? Oh, I have the signs wrong. This should be where this is true. Okay. Sometimes it just takes a simple print statement. So now we have double counted clearly, or maybe not just double counted, but something weird. Okay, so 2, 1. This is more right. The 2. Oh, this is wrong because this 2 should match this 2, and it pops it, but it should have a total. This one should not be. Maybe it should be a 2, but this gets to 204. It's a little bit weird. So okay, I see. So if it's equal, we actually don't want to pop it. I think that's maybe a better read. I thought you do, but maybe that's fine. Okay, so 4 and 6. 4 is definitely going to be wrong because we know that we need to do the other side. This should at least be, I think the right answer here should give us 5. Even though I know, because we didn't do the other side. Let's see. So this one, this part is wrong. This one should give us 1. So it is equal. Yeah, because I do the math by the delta of the heights. That's not right. This is not right. This math is not right. What we actually want is this part. But we actually want h minus that ch. In this case, h is bigger than ch times the current width. Okay. Man, I am really bad at. So my excuse, if you will, is that usually I would say I would have pen and paper, and that's how I draw them out to do the math. But I'm trying to do everything in my head, and clearly I'm doing that terribly. But yeah. Okay, so 1, 2, 2 pops off the 1, but there's nothing to the right. So I think this should. I think that's the issue. Is that okay? Okay, if length of stack is greater than 0, then, or if this is equal to 0, then actually total is equal to 0 because that means that we haven't found one that's bigger than what here. And width is also equal to 0. So we don't do that. So maybe that's a little bit too. This feels a little yucky to do, but yeah. Oh well. Okay, and then now let's abstract this, and then do it from the other side as well. So let's just say we have def get water. So then now you can just do get water heights plus get water heights of reversing the array. So this should give us 6 if we're happy. I want to try some obvious examples. Let's just say 100, 0. I mean, okay. Oh, maybe I have gotten a little bit lazy on this one. So the reason why this is wrong, and I have to double check that this isn't the case for this one actually, or on Q on this one, because why doesn't that happen? Because basically we don't handle the equal case well. I think now we can pop the equal because now we do the total correctly, maybe. Okay. Why is that? That's weird. Because basically we have 101, we added 10, there's no water, and we add another 10, and that should have added thing here. I actually imagine this to be double, so it would still be wrong, but at least wrong in a consistent way. No, we definitely want this to terminate though, actually. No, I'm wrong here. But then now we double count because going from left to right we have the symmetry of 190. How do I handle the symmetry in a good way? Okay, I think what you can actually do is take the peak, and it doesn't have to be, as long as you take any one peak, so it's, you can think about it as like we said, a pyramid, right? So we take the left half and the right half. For me, I got a little bit lazy, but we can actually take the peak. So yeah, so because you go max height, and then we just separate from left to right and right to left. So yeah, okay. So peak is heights of index of peak index, say. And then now we can just do get water from, let's see. Which way is it? So now we have the peak. We want to go from right to left. So this is actually, yeah, P index. And then here, this should be from P index on, and then reverse it. Okay. Which you got heights of index, what? Oh, because the n is different now. We don't even need n here. That's just a silly mistake, actually. Pretty bad mistake, but a silly one. Okay, so we fixed this issue, but we didn't fix this one, which is unfortunate. Okay. Why is that? Tell me why. So the peak is going to be 3. Did I do it backwards or something? Let's see. This has been a very long production. Kind of tired, need some sleep, but that's okay. Okay. Okay, so it just seems like that I forgot to add in the 3. Off by 1 sucks. I think this should be good. Yep, okay. Let's, is this good enough? Okay, I say, let's just say I'm YOLO enough to let's give it a go. Hopefully this is good. Not super confident. Oh, I forgot the empty case. Okay, fine. And only because of this, but yuck. Okay, fine. Actually, the funny thing is that I've been better at testing the empty case lately, but some of these farms for random reason has this, where the ones that I do test, like even yesterday, the length of the array is 1, so I don't know. Mistakes were made. That's okay. Click done submit. Let's see how that goes. Maybe I'm lagging. Am I lagging? Okay, there we go. I guess I'm lagging a little bit. Okay, cool. Actually, that was pretty fun. For some definition of fun. Yeah, so what is the time, right? This is going to be linear time, and the way that I'm doing is linear space for the stack. We only look at each, so okay. Let's go over it a little bit. This just takes the height, so that's going to be linear time. This is a linear search, so that these two are going to be linear, and then we break them up in 2 arrays, right? Where the peak is, and here the key thing to note is that I think one thing that beginners do is that you see a for loop and a while loop, and you think it maybe n square, but actually another way to think about it in a more tighter way is that for each element in height, what happens to it? Well, for each element in height, it can only be pushed on the stack once here, right? And it can only be popped once because, well, it can only be popped if it's in the stack. So that means that for each element, you can only, or you are only pushing and popping it once, and therefore for n elements, there'll be O of n space and time. Yeah, that's all I have for this one, I think. Let me know what you think. I know this is a more of a standard problem, and I say standard only because it gets asked a lot, not because it's easy or anything. And as you can see, because it took me 25 minutes to do it, but this is how I would do it in an interview. This is how I've done it live. So let me know. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Have a great weekend. Have a great August. Hope you had a great July. Stay cool, stay healthy to good mental health. I'll see you later. Bye bye.